This lesson's on factoring polynomials. So when we say factoring, we're looking actually for the roots of a quadratic in this case, since we're dealing with quadratics. So factoring, we just want to find a set of two things multiplied together that are going to form that quadratic. And the easiest way to do it is what we call diamond math. So diamond math, you end up setting up, surprise, surprise, a diamond. What you want to put on the top is, well, first let's talk like this. You have ax squared plus bx plus c. It matches up with the following terms. Okay? So when you do diamond math, what you want to do is put c on top, so we have negative 5. Then put b on bottom, negative 4. And a we're not really doing anything with yet. What you want to do then is find what multiplies to 5 and adds to negative 4. So the easiest thing to do is list out the factors of 5. So we have 5 times 1. That's it. So it has to be a 5 and it has to be a 1. But which one's positive, which one's negative? Well, how you decide that is the biggest one always follows the denominator's sign, the bottom of the diamond sign. So it's negative 4, that means this is going to be a negative 5. So let's test it out. Negative 5 times 1 is negative 5. Negative 5 plus 1 is negative 4. So our answer is x minus 5 times x plus 1. That's our solution. Now let's look at our second example down here. X squared minus 3x plus 2. So we make our diamond, put the c value on top, put the b value on bottom. The factors of the top of the diamond are 2 and 1, so 2 and 1. They multiply to 2. How are they going to add to negative 3? Well, remember that rule I said about the big one has to follow, the bigger of the two numbers has to follow the bottom of the diamond. So this for sure has to be negative. But then negative 2 plus what equals negative 3? Plus negative 1. So then these are your solutions. So x minus 2 and x minus 1. Now from there you actually can find your roots. So you would set x minus 2 equals to 0 and x minus 1 equals to 0, solve for x. But we're just factoring right now, not doing the roots. Now, that's when a was equal to 1. You couldn't see the 1s, but they're actually there, they're hidden. But what happens when a isn't 1? Here a is 2. How do we do that? Well, it's the same diamond method, just a little bit of an extra step. The diamond method actually is taking a times c, putting that on the top, and b is going on the bottom. Over here, we were taking negative 5 times 1, it's just negative 5, so that a value didn't really matter. Now it is going to, since that a value is not 1 anymore. So when we're doing our example, we're going to write, let's just do it right here, 4 times 2, which is 8, and then put 6 on the bottom. List the factors of 8. You have 8 and 1, 4 and 2, and that's it. So which ones are going to add or have a difference of 6? Well, 4 and 2 are, because positive 4 plus 2 is equal to 6. So that's our diamond. We're going to be using these two things right here, those two sides of the diamond, but in a little different manner. We're going to write down our first term, our x squared term first, and then we're just going to tack on these two that we just found. The 4 is right there, and the 2 is right there. Maybe I should start using a different color, huh? Right there. Now, why does that work? Well, look at it. 4x plus 2x, that's 6x. That's that middle term. We just split it up a little bit. And then at the end, we have plus 4. The reason why we split it up is because we're going to factor, take out a multiple that each of these sets have in common. So I grouped them in 2s. What do both of these have in common? They have a 2 in common and an x in common. So I can pull out a, let's try it like this, 2x. So if I pull out 2x from 2x squared, I'm left with x. If I pull out a 2x from 4, I'm left with 2. Now I have to do the same thing over here. What can I pull out of both of these terms? Well, I can pull out a 2. If I pull out a 2 from this one, I'm left with x. If I pull out a 2 from the 4, I'm left with 2. Now, this is the part you have to remember. You need to have these be the exact same because they are one of your solutions. If it didn't work out like that, then you did something wrong. Check your multiples, whatever factor you took out, check that. Or even check your diamond, maybe your diamond didn't work. Your second solution, or excuse me, the second part of your factor is these guys right here. You just put them right in there. Okay? And then this is your solution. 2x plus 2 times x plus 2. That is the factored form of this right here. Okay? Let's try to do that now with this example in number 4. If you want to, try it by yourself, pause the video, and then see what we come up with. Okay, but we're going to get started. So we multiply the c and the a value. So we have 36, and then the b value goes on bottom. List out your factors of 36. So you have 36 and 1. You have 18 and 2. You have what in 3? That is 12 and 3. And then we have 9 and 4 and 6 and 6. So, what multiplies to 36 and adds to 12? Well, we can do 6 and 6, right? So with those, we want to put them in for this 12x. So we write 4x squared plus 6x plus 6x plus 9. Notice that these are the ones that have the x values with them. And then we go ahead and do our grouping. And now let's go ahead and take out an x for sure, because both these terms have an x, and they both look like they have a multiple 2 in common. So that would leave us with 2x plus 3. Plus, what do both of these have in common? Looks like they have a multiple of 3 in common. So we're left with 2x plus 3 inside there. They match in the parentheses. That's one solution. Combine these guys for our second part of the solution. So, right here's our answer. 2x plus 3 times 2x plus 3. If you want to, you can check your answer just by foiling. So we'll take 2x times 2x, which is 4x squared, 2x times 3, which is 6x, 3 times 2x, which is 6x, and then 3 times 3, which is plus 9. This will combine, so we have 4x squared, plus 12x plus 9. Same thing we started with. So now you know how to do that. If you have any questions, come in and talk to us.